Hello, thank you for joining me today at Galt Solutions. My name is Barry Keating, Professor of Finance at the University of Notre Dame, as well as one of the co-authors of the book, Business Forecasting with ForecastX. In this segment, I'll be discussing the special case of new products and how to forecast them using the ForecastX wizard. New products present a very difficult problem for forecasting because we have very little data, very few data points. So for a time series model to pick out the pattern and forecast into the future becomes relatively difficult. So what we do is we use a piece of economic theory. We know that all products follow a life cycle. I've got a life cycle graph on the screen in front of you. It turns out that all products begin out with growth in an embryonic stage, then they go through a rapid growth stage, and then what happens is growth begins to fall off in a mature stage, finally reaches a maximum, and then actually may begin to decline at some later time. Let's take the case of a new product, in this case, high-definition television. Pretend that we're back at the end of 2002. High-definition televisions are relatively new, and we only have 4 data points. This is a time series data set, but it's a yearly data set, and it turns out that we only have 4 years of data. Very few people in the United States by the end of 2002 had a high-definition television. There was a reason to forecast high-definition television at this time because television stations wanted to know when they'd be able to turn off their analog transmitters. The federal government said they couldn't turn off those transmitters until the market had 85% penetration. 85% of the people in the market had to have an HD television. So what we'll take a look at are HD television cumulative shipments. Now, one of the things we need to know in order to forecast new products is the maximum number of the new product that we could sell. You have to actually input that as a piece of information to the ForecastX wizard. The number doesn't have to be exact, but it helps if it's in the ballpark. I'm going to use the number 248 million. The reason is, in 2002, there were 248 million televisions in the United States. I'm going to assume that the maximum number of HD TVs we could sell would be a replacement for every one of the analog televisions in existence at that point in time. So I call up the ForecastX wizard. Notice we only have 4 data points this time. The ForecastX wizard has correctly identified the data as annual, the fact that we have 1 label. This time we can actually extend out the number of forecast periods quite far. In fact, we might want to extend it out to something on the order of 30. This is the one model in time series forecasting for which we can get medium and long-term forecasts. I'm going to select New Product Forecasting from the drop-down menu, but notice that this time I need to actually put something in at least one of these dialog boxes. So I'm going to click the Edit Parameters button, and in the maximum box I'm going to put the number 248. The reason being, I'm indicating to the model that the maximum number of HD televisions we could probably sell would be 248 million. Remember, the HD TVs are denominated in millions. I've already selected the correct statistics to look at, and I'm going to use the audit trail, which I've set up in the Reports tab. So I'm going to hit Finish and generate the model. One of the things you'll notice is that this model is very different than others we've looked at in exponential smoothing. The actual data ends right where I have the cursor on the left-hand side of the screen. There are only 4 data points. They're at the very beginning of this S-curve. The red curve that you see stretching out to the right is actually the forecast, which takes on an S shape. And that's the way that we actually expect HD television sets to roll out in the future. As a matter of fact, many people have HD TVs now, and this forecast was not very far from what actually happened. Now, in this particular case, it doesn't make a lot of sense to take a look at the accuracy statistics the way we have with the other exponential smoothing models. The accuracy statistics, actually correctly called fit statistics, only show you accuracy measures of how well the model fit in the historic period. But our historic period in this particular model only has 4 years of data, while we've asked for actually 30 forecast periods. So it's probably the case we're just going to have to accept the model and assume that the S-curve is correctly drawn given only 4 data points. Now, you can't expect a model like this to be as accurate as a Holt-Winters model, which may have 30, 40, maybe hundreds of data points on which to match a pattern. But we've given this model a little help. We've told it it's going to be an S-curve, and we've told it the maximum number of HD TVs we could actually sell. And that's the special case of how to estimate new products.